Hello and welcome back. In this video, we're going to talk about interpreting definite integrals involving velocity. Let's say the position of a particle moving on the x-axis is given by x of t. The velocity of the particle is given by v of t measured in feet per second. If we were to encounter this definite integral expression, integral from 3 to 5 of v of t dt, we need to remember that velocity is the derivative of position. And so this is the same as x prime of t dt. And when we integrate x prime, we're back at x, which we would then evaluate from 5 to 3. Sorry, from 3 to 5. This represents the change in position between the time values of 3 seconds and 5 seconds. Our answer would be measured in feet. So it's the change in position in feet between t equals 3 and t equals 5 seconds. If we were to encounter this definite integral expression, now we've got the position at time 3 plus this change in position. Well, if we take the initial position and add the change in position, we're going to get a new position. Again, we might take a moment to remember that we're integrating x prime from 3 to 5. And so when we integrate x prime, we'll have x of t, evaluating from 3 to 5. We'll need to plug in the 5 and then minus plug in the 3. Notice how these terms cancel out, and we're left with the position in feet at time t equals 5 seconds. At time t equals 5 seconds. Oops, went off the screen just a little bit. What if we were to encounter this integral expression? Notice those absolute values change up the meaning quite a bit. Without the absolute values, we were finding displacement or change in position. Now that I have the absolute values, I'm going to get the total distance traveled in feet between t equals 3 and t equals 5 seconds. Okay, I've got one more for you. Let's say I encounter this definite integral expression. This is a tough one. A lot of people ignore this coefficient here, but this coefficient is really important. You might realize, how do we get 2? Well, we were probably doing 5 minus 3. And this makes it look a whole lot like the average value integral. So I would interpret this as the average value of the velocity in feet per second between t equals 3 and t equals 5 seconds. Thanks for listening and enjoy calculus.